Section 1, Video 3, Area of Trapezoids, Rhombi, and Kites. We'll start with the area of a trapezoid. Now if you look at the formula we give you, it looks a lot like the formula for a triangle. 1/2 base times height. So in a triangle, we say take the base times its height, we have a 90-degree angle, and we're all set. The problem is, with a trapezoid, we have two bases. So if you look at the formula, what they've done is they've added the two bases together, and that has taken care of the difference. So in other words, when you take half of the base 1 plus base 2, you get the average. And if you remember, that would have been called the mid-segment length, and we had that a couple of units ago. So let's see what this formula does for us. If we take an example here, it says what is the area of a trapezoid when we give you the bases 7 and 21 and a height of 2. So as before, we have a formula. So we take 1/2, and the height in this case was 2, and we take the two bases and add them together. And in doing so, we would get the area of 28, and there are units with this one, so 28 centimeters squared. Now sometimes it's nice to see what the picture would have looked like from a sentence. So if we take that word problem and applied it to a picture, we would have had a base of 7, a base of 21, and then a height at a right angle of 2. So that's kind of how you could, and you are welcome to draw it out to see if it helps you make it more clear. The next question: what is the height of a trapezoid when they give you the area of 200 and the bases 15 and 25? So we are going to work backwards on this one, and we have the formula, which we know as area equals 1/2 base, or excuse me, base 1 plus base 2, pardon me, base 1 plus base 2, and then times height. And order of that doesn't matter, but if we plug in what we know, we have area of 200, and we have 1/2. We don't know the height, but we do know the bases, and that is 15 plus 25. So we're trying to solve for h. So if we do some calculations here, 15 plus 25 is 40. 40 times, this is a 40, times 1/2 would give us 20, and then we still don't know the h. Divide both sides by 20, and our height would be 10, and it has units again, so we'll say centimeters. Next to we have area of a rhombus, but there's two formulas that we have. Area of a rhombus is S times H, which should look familiar, but we are used to seeing it as base times height. But since it's a rhombus and we know that all sides are equal length, then we would just say all the sides are S, so then it becomes S times H, because the base is going to be now called S, which is typically what you would do for a shape that has all sides equal length. We also have another formula that we could use depending upon the information we have, and that is 1/2 diagonal 1 times diagonal 2. And to clarify, it means the total length of the diagonal and not what it looks like to be just half of the diagonal there. So if you know the full lengths of the diagonal, you multiply them and take it times 1/2, and you'll have the area of the rhombus as well.